Hey everyone, welcome to my channel. Whether you're new or whether you're returning, thank you for being here and I hope you'll continue to come back. So today I'm going to be talking more about simplifying radicals, also known as roots. In my first video, which I'll link up here in the I talked about how to simplify radicals that only have numbers underneath. But today I'm going to throw in variables and also coefficients. So if that sounds interesting, then just keep watching. All right, I'm going to start off with just a number one here, but it has a coefficient, and then I'll remind you of the rules here that will help us with ones to come. So on this first one, now if you remember my last video, or if you haven't, then stop the video and go watch it. But what you want to do is you want to do a factor tree on the number that's underneath. So with 24, you can break that down to 4 and 6, 2 and 2, and then 2 and 3. Now, when you're taking a square root of a number or of variables, you're going to find pairs that get to exit the root. So I like to circle the pairs and then put boxes around the ones that can't pair up, because numbers that aren't the same can't pair up. So everything that is a pair gets to leave the root, everything without a pair stays underneath. So this is 5 root 24. That means 5 times the square root of 24 because there's no visual operation. It's implied multiplication. So don't lose track of your 5. How this can be written is we're going to keep the 5, we'll put the multiply, and then the pair of 2's leaves, but we only write a single 2. And again, that is because 2 times 2 is 4, and the square root of 4 is just 2. So then we will have the square root after that, and then this 2 and this 3 are going to stay underneath. Now again, everything's still multiplication. So after you've written all those numbers there, then you can simplify it down to 5 times 2 being 10, root 2 times 3 is 6. So 5 root 24 simplifies down to 10 root 6. Anything that pairs up leaves, anything that doesn't stays underneath, and then if you had any sort of coefficient or multiple coefficients, they're all just multiplied outside and you're good to go. So I hope that makes sense and is a good little refresher from last time. Now, on ones like this, I briefly mentioned it before, but when you have a square root and a squared power, those are opposite operations. So if you have anything with a square root and a squared power, those will just cancel each other off, leaving the 7 as the final solution. Now that is going to translate down to variables as well, or anything really. So if you are squaring something that's square rooted or vice versa, they just cancel off. So the answer would just be x. That pattern is going to continue here. A cube root and a cube, they cancel out. So the answer is just y. Fourth root and a fourth power cancel out, just leaving a z. So that is something that can be really helpful when you are learning how to simplify roots with variables. So let's get into some more complicated ones and keep this in mind and it will be helpful. Here's our first example. One thing you can do is to root each piece individually. In fact, you actually can write them separately. Square root 32, square root x to the 4th, square root u to the 5th. But I like to keep it all together, but know that that's the idea that we're doing, is we're going to root each piece individually. So I'm going to start with the number and then we'll get into the letters. So let's break down 32 like we did on the previous board, I guess. And all of the pairs are going to leave the root. So this is a pair and this is a pair, but this one doesn't have anybody to pair up with. So I like to be very organized here. I'm going to put the root symbol and we're going to put everybody that pairs up out here and everybody that can't pair up here. So this 2 gets to leave. Again, it's because the square root of 4 is just 2. And then this 2 is also going to get to leave. Those are multiplied because all of these are multiplied. And then this 2 is going to stay inside. So let's move on to the x's. Now you can do the same thing. You can write a factor tree, or you can just write out what x to the 4th means, which is x times x times x times x. So then just like I did with the numbers, I'm going to look for pairs, and every pair gets to leave. So x and x pairs up and leaves. Now again, the reason for that is because x times x is x squared. So what's the square root of x squared? As I showed on the previous board, it's just x. So that's what we're writing there. Looks like math magic, but there's actual math behind it. Yeah, I'm going with it. So then these get to pair up and leave as well in the same idea. Totally erased my root there. Professional. All right, so let's do the same thing with the u's. So u to the 5th would be u times u times u times u times u. Now you can see that this is pretty tedious having to write them all out. Like what if that was u to the 15th power? But as you're first learning, it does help to write it all out, in my opinion. So they're going to leave, this one is not. So we have another u here from that one, and then another u here, I'm gonna squeeze it in there from that one, and then this one is going to stay underneath. So there's a lot of arrows going on, but hopefully you can see where everything ended up. So now all you want to do is multiply everything outside that you can, multiply everything inside that you can, and then you're done. So 2 times 2 is 4. X times x is x squared. U times u is u squared. Root 2 times u is 2u. So that is our simplified version of that root right there. Now it looks a little bit longer than the original, but there's a lot of benefits on being able to simplify roots down. So definitely get into that habit. I hope it makes sense. Let's do a couple more. On this one, we can start off by breaking down the 64 as normal. You can just also ask yourself, what is the square root of 64? And that is 8. So you could just put an 8 outside, but let's do a factor tree for the sake of practicing. Let me just do that really quick. And then we would circle all the pairs because it is a square root. So it looks like we're going to have 2 times 2 times 2 outside the root. All right, so let's do that. So we have 2 times 2 times 2 outside the root, no 2's underneath. Now, as far as s to the 11th, you can write out 11 s's, and maybe it will help you to like visualize that in your head. But keep in mind that you're going to be circling pairs anyway. So if you think of 11 anythings, then how many pairs are in 11? So what you can think is that in 11 things, there are 5 pairs with 1 left over. So what that means is the 5 pairs are going to leave, giving us s to the 5th. That means 5 pairs of s's. And then the one that's left would go underneath here. Now you would see that if you actually wrote out 11 s's. So that's a little bit shorter of a way to do that. Let's do the same thing with t to the 7th. So if I have 7 anythings, let's say 7 tacks, then that means I have 3 pairs of tacks with 1 left. So 3 pairs means I'm going to have t to the 3rd, 3 pairs of t's, 3 pairs of tacks, and 1 left over there. And that's your final solution. So whichever way makes more sense, or you can kind of mesh the two by saying, well, if I picture writing out 11 s's and 7 t's, then how many would be exiting? So to finish this off, 2 times 2 times 2 is 8, s to the 5th, t cubed, square root, st. That would be your fully simplified version. So let's do a couple that aren't square roots, but are cube roots and 5th roots, and see how those ones work out. Remember that a cube root means groups of 3 are needed to leave the root. So let's break down 40 in the same way. Let's do 5 and 8, 2 and 4, 2 and 2. So that group of 3 2's is going to leave that cube root. There's not 3 5, so he's going to stay underneath. Now again, the reason we're only going to write a single 2 is because technically it's the cube root of 2 cubed, and that cancels that. Therefore, we just write a single 2 on the outside. So we're going to have a 2 on the outside, keep your cube root, and the 5 is going to go on the inside. So now with the p's, now again, we're looking for groups of 3 or triples. So if we have 5 peaches, we have one group of 3 with 2 left. So however many groups of 3, you have 5 peaches. Whoa, 5 peaches. Oh, I'm doing good with the camera today. Then we have one group of 3 and then 2 left. So that means we're going to have a single p outside because that's one group that was 3 underneath here. And then 2 left. So we're going to have p squared underneath there. Now again, that would be the same as if you just wrote p, 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 and said those 3 leave, these 2 don't. So when in doubt, write it out the long way, but it can be helpful to start thinking of them in terms of groups. Now q to the 7th, so you have 7 quarters, right? So we have 2 groups of 3 because that would make 6, and then 1 left. So 2 groups of 3 means we're going to have q squared. This number is how many groups there were. And then we have 1 left. So we have 1q left. So that is kind of written far apart because I was leaving myself room, but that is our final solution. Questions, comments? Leave them in the comments below. Let's do a 5th root next. This one looks fun, right? Right, yes, let's do it. Now I put a coefficient in front. Just remember that is going to be multiplied by everything that leaves the root at the very end. Now I also have a number and 3 variables, but again, as long as there's no plus or minus, then you can just root each piece individually, no harm, no foul. Now since this is a 5th root, we are looking for groups of 5. Whether you're talking about numbers or letters, groups of 5 are going to leave the root because the 5th root of anything to the 5th is just that thing. All right, so let's break down 96 first thing with a factor tree. So we'd start off with 3 and 32, 4 and 8. It doesn't matter what numbers you use for your factor tree. You'll always have the same numbers left over at the end, so don't worry too much about that. All right, so we have 5 2s, so that means that they're going to leave. And then we have a 3 that can't leave because we don't know the 5th root of 3. All right, so I'm going to keep the 6. Don't lose that. Don't say, oh, I'll deal with it later. In math, when you say I'll deal with it later, it means I'm going to forget about it later. So let's not. So we're going to put it down there. We're going to organize very, very well. So we have the 6 times. Now I'm going to put the 5th root over here, again, so I don't forget what type of root I was taking. That's super crooked. Well done, well done. We're just going to go with it, okay? All right, so then the 2's come out, and we write a single 2 because the 5th root of 2 to the 5th is just 2. The 3 stays underneath here. All right, now x to the 11th, how many groups of 5 x's would that be? So there would be 2 groups with 1 left. 2 groups of 5 with 1 left. So that means we have x squared outside and then 1x left inside. Y to the 7th would be 1 group of 5 with 2 left. So that would be 1y outside and 2 y's inside. Now z to the 19th. Now how many groups of 5 are in 19 z's? That would be 3 because 3 groups of 5 is 15 z's and then there'd be 4 left over. So this is 3 groups and 4 left. So we have z to the 3rd and then z to the 4th here. Now let's multiply whatever we can here, namely the 6 and the 2. So we would have 12 x squared y z cubed times the 5th root of 3x y squared z to the 4th. And that would be your final solution. I hope these are making sense. What I'm going to do next is write up some practice problems for you. And then as I usually do, I ask you to pause the video and then I'll come back with all the answers written out. So those are coming up. Here are some problems to try on your own. I like to give you guys practice problems so that you do have a chance to give them a go using everything that you learned in the lesson or the video. See how you do. So pause the video and work these out, and I'm going to pause and work them out. And when I come back, we can check our answers together. So let's do that. All right, I'm back. You're back. How did it go? Let me know down in the comments if you did these and if you got them right, or if you had any questions. I'd be happy to correct anything. I've broken down the numbers for you and circled the groups, and I also reminded you that with the 4th root, you're looking for groups of 4, and with the cube root, you're looking for groups of 3. So I hope that you guys got these right. Let me know down below, and let me know what other type of root videos you'd like me to make. There are so many we can go over. Solving equations with roots, rationalizing the denominator or numerator, all sorts of things. So let me know what you'd like me to cover. Thanks so much for joining me today. It means a lot that you would support me and my channel, and I hope that you'll come back. So please subscribe, like the video, and let me know what else you'd like me to cover. I am just compiling a list and I'm excited to keep going for you guys. So I hope you have a beautiful day wherever you are, and I can't wait to see you in the next one. Bye.